Hello all. So this is assessment problem 4.7, and in this question we have to find the power delivered by the 8-volt source and similarly the power dissipated in the 8 ohm resistor by using the mesh current method. So in mesh current method, what are the steps which we have to follow? In first step we have to consider each mesh, and in each mesh we have to suppose a specific amount of current. So this is mesh number 1, this is mesh 2, and this is mesh 3. In this mesh the current flowing is I1, the current flowing in this mesh is, let's say, I2, and the current which is flowing through this mesh is I3. Okay, so let us consider these meshes very separately. So I am let me represent this mesh with black color, this one with the red color, and the third one, this one with the green color or blue color. Okay, so these are three meshes. So for mesh number one, let us apply KVL here. So by applying KVL here, we can see that here the current is entering through the negative terminal and coming out from this positive terminal. So this is the voltage rise. So let me write here 80. So 80 is the voltage rise, while the other two elements are the resistors, and in resistors we can always see that there is a voltage drop. So 80 is equal to the 5 multiplied by the difference of the currents. So this is I1 minus I3, the two currents which are flowing through this resistor. I1 is flowing through this direction and I3 is flowing through this direction. So this is I1 minus I3. Similarly, the other resistor is this 26. So 26, and this is I1 minus I2 because it is at the junction of the first and the second loop. So here you can see that there are two currents which are flowing through 26 ohm, which are I1 and I2. So let me simplify it. So by simplifying it, we will get 5I1 minus 5I3 plus 26I1 minus 26I2. This is equal to 80, and by simplifying it again, this would become 31I1 minus 26I2 plus, or sorry, this is again negative. So this is minus 5I3. This is equal to 80. So let me call it equation number 1. Okay, so this is equation number 1. Let me jump towards the mesh number 2 and applying KVL here again. Okay, so when I apply KVL here, I can see that there are three resistors which are basically dropping the voltage across them. So the first one here will be 26 multiplied by I2 minus I1 plus 90 I2 minus I3 and plus 8 I2. Okay, so this one is what? This one is the last resistor, this one, and this is equal to 0. These three are equal to 0 because of the KVL. So let me simplify them. This would become 26 I2 minus 26 I1 plus 90 I2 minus 90 I3 plus 8 I2. This is equal to 0. So by rearranging them, minus 26 I1, this is 26 plus 90 plus 8. So this would become plus 124 I2, and similarly minus 90 I3. This is equal to 0, and this is equation number Okay, so now the last loop, this is the last mesh, and this is mesh number 3. And in mesh number 3 again we have 3 resistors which are consuming the voltage. So the first one will be 5 into I3 minus I1, the difference of the current which is flowing through this first resistor. Similarly the second one, which is this 90, and again I3 minus I2, and plus this third one. So now simplifying this equation, this will be 5I3 minus 5I1 plus 90I3 minus 90I2, and similarly this is plus 30I3, this is equal to 0. Rearranging it and summing all the similar terms, this would become minus 5I1 and this 5I3 plus 90I3 plus this 30I3. This would become plus, okay, so let us first add this I2 term. So this would be now 5 minus 5I1 and then minus 90I2, and now adding all the terms associated with I3, this 5 plus 90 95, and this 30 25 125 I3, this is equal to 0. So now let us call this equation number 3. So now we have 3 equations and 3 unknown. We can use any method, and by using that method we can easily find out the solution of of these 3 equations. So let me write them in matrix form. So in matrix form, let me write them in green. So in matrix form it would become 31 minus 26 and minus 5. Similarly minus 26 124 and minus 90, and minus 5 minus 90 and 125. This is the matrix fat matrix. This is now I1 I2 I3, and the last term here would be 80 0 and 0. So this is our system of linear equations, system of linear equations. So this is basically 3 by 3 matrix. This is 3 by 1, and this is again 3 by 1 matrix. So solving it and finding the values of I1 I2 I3 is not that much easy. You have to make all the calculations, you have to use the Cramer's rule or any other method, whatever you like, to find the values I1. So when you will find the value of I1, you can easily find out the power which is provided by the 80 volt source. So that would be equal to the P is equal to I into V. So as the current in the first branch or the first mesh is basically I1 and the voltage is 80, so by this equation we can easily find out the power which is provided by, or energy which is provided by, this 80 volt source. Similarly, in order to find the power which is dissipated across the 8 ohm resistor, we have a formula which is I square R. So the I which is basically in the third loop or in third mesh, so that is basically I2, sorry, this is in the second loop. So because here we can see that this is the 8 ohm resistor across which we have to find the power dissipation. So here the current is 2 ohm, and similarly the current here is I2 and the current here is I1. So that's why I'm writing here I1V, and here I will write I2 square into R. Okay, so that's why I'm using the equations here, this one. So I2 square into R, and the value of R is 8. So by writing the values which we have found out earlier, we can easily find the values here. So that's it. That is the solution which is related to the mesh current method. We can find out the solution of any circuit. Related to any circuit, we can find out all the unknown quantities which we are asked to find by this method. So thank you so much, and I will see you in the next.